Hello friends, today we will discuss the topic binomial distribution. Bernoulli trial. A Bernoulli trial is a random experiment in which there are only two possible outcomes, either success or failure. Example, if I toss a coin, then it has two possible outcomes, either head occur on the uppermost face or tail occur on the uppermost face. So this is example of Bernoulli trial. Then we discuss binomial distribution. Binomial distribution. Here we consider n independent Bernoulli trial. Here we consider n independent Bernoulli trial, and it has, suppose, x successes and n minus x failures. Suppose P is probability of success. Suppose P is probability of success and suppose Q is probability of failures. Suppose P is probability of success and Q is probability of failures. We know that total probability is 1. P plus Q is equal to 1. Let random variable x, where values of x are either 0 or 1 or 2 up to n, because we have considered n Bernoulli trials. Number of successes, and we know that these trials are independent. These are independent. So we get probability of successes and failures. We know that these successes are x times and these failures are n minus x times. So this is equal to, as these successes and failures are independent, therefore we can write these as probability of s, p of s up to p of x times into p of f up to p of f n minus x times, and probability of success, its notation is p. We can write this as p x times, and notation of failure is q. We can write this as q. This is n minus x times. Therefore this is p raised to x into q raised to n minus x. P of s up to s x times into f n minus x times is equal to p raised to x q raised to n minus x. But x successes from n trials we can obtain these NCX ways, and probability of each of which is p raised to x into q raised to n minus x. Therefore, our final answer, probability of x equal to small x is equal to probability of getting x successes and n minus x failures in n number of independent trials is equal to NCX p raised to x q raised to n minus x. This is called probability mass function of binomial distribution. Properties of binomial distribution. First property, its probability mass function P.M.F of binomial distribution with parameters n and p is probability of x equal to small x. We can denote it as probability of x is equal to NCX p raised to x q raised to n minus x, where x is 0, 1, 2 up to n, and this is equal to 0 otherwise. Then second property, mean of binomial distribution is n into p. Next, third property, variance of binomial distribution is npq, or we can write this as n into p. Value of q is 1 minus p. Fourth property, mean np of binomial distribution is always greater than variance npq. And fifth property, if n plus 1 into p is not an integer, then mode of binomial distribution is integral part of n plus 1 into p, and if n plus 1 into p is integer, then the mode are Suppose this n plus 1 into p is k, it is an integer, then modes are k minus 1 and k. Also note that for binomial distribution p plus q is 1. If mean and variance of binomial distribution are 4 and 2.4 respectively, find probability of 5 successes and at most 1 successes. Here mean is given 4 and we know that its formula is NP. Variance is given 2.4 and we know that its formula is NPQ. Therefore NP into Q is 2.4 is given. Value of NP is 4. Therefore 4 into Q is 2.4. Therefore Q is equal to 2.4 upon 4 is equal to 0.6. And also we know that P plus Q is 1 and Q is 0.6. So P plus 0.6 is 1. Therefore value of P is 0.4. Then for 5 successes, probability of 5 successes is equal to probability of x equal to 5 ncx p raised to x q raised to n minus x. Then we have to find value of n, as n into p means mean is 4 and p is 0.4. n into 0.4 is equal to 4. Therefore n is equal to 4 upon 0.4. 4 upon 0.4 is 10. Therefore value of n is 10. Here we use value of n 10. See, x is 5 into p 0.4 raised to x is 5 into q 0.6 raised to 10 minus 5. This equal to formula of 10c5 is 10 factorial upon 10 minus 5 factorial into 5 factorial. Formula of NCR is n factorial upon n minus r factorial into r factorial. So here 10c5 is 10 factorial upon 10 minus 5 factorial into 5 factorial into 0.4 raised to 5 into 0.6 raised to 5. This is equal to 10 into 9 into 8 into 7 into 6 into 5 factorial upon 10 minus 5 is 5 factorial into 5 into 4 into 3 into 2 into 1 into 0.4 raised to 5 into 0.6 raised to 5. This 5 factorial will cancel with this 5 factorial. This 5 into 2 is 10 is cancelled with this 4 2s are 8, 3 2s are 6. This is equal to 9 into 2 into 7 into 2 into 0.4 raised to 5 into 0.6 raised to 5. If we calculate this, we get final answer 0.2007. Then second case, probability of at most one success. This is equal to p of x less than or equal to 1. This is equal to probability of x equal to 0 plus probability of x equal to 1. Here n is 10, p 0.4, q is 0.6, nc 0 P raised to 0 Q raised to n minus 0. This is for phi of x equal to 0. For P of x equal to 1, NC1 P raised to 1 Q raised to n minus 1. N is 10, 10C0. P raised to 0 Q raised to 10 plus 10C1 P raised to 1 Q raised to n minus 1. P is 0.4, Q is 0.6. This is equal to 10 factorial. NC0 is 10 factorial upon 10 minus 0 factorial into 0 factorial. P raised to 0, anything raised to 0 except infinity is 1. So P raised to 0 is 1 into Q. Q is 0.6 raised to 10 plus 10 factorial upon 10 minus 1 factorial into 1 factorial into P 0.4 raised to 1 into Q 0.6 raised to n minus 1 means 10 minus 1, 10 minus 1 means 9. This is equal to 10 factorial upon 10 minus 0 factorial. 10 minus 0 is 10 factorials. 10 factorial upon 10 factorial. 0 factorial is 1 into 0.6 raised to 10 plus 10 factorial upon 10 minus 1 is 9 factorial. 10 factorial into 0.4 raised to 1 into 0.6 raised to 9 upon 10 minus 1 factorial means 9 factorial. 10 factorial upon 10 factorial is 1, 0.6 raised to 10 plus 10 factorial, you can write this as 10 into 9 factorial upon 9 factorial into 0.4 raised to 1 into 0.6 raised to 9. 9 factorial is cancelled with this 9 factorial. 0.6 raised to 10, 0.0060. We can check this on calculator. Then 10 into 0.4 raised to 1 into 0.6 raised to 9. This is equal to 0.0060 plus 0.0403, and final answer is 0.0463. Therefore, probability of at most one success is equal to 0.0463.